Today we are learning about circles. In mathematics, a circle is the set of all coplanar points equidistant from a given point. That given point is the circle's center, and it does not lie on the circle. The circle is only the set of points, forming a curved line returning back on itself, that are in the same plane and same distance from a center point. The circle itself is not the inside space, the center, or the outside space. Without its identifying center point, the circle is nameless. Circles are named by their centers, so take the circle and place point I in the middle. Now we have circle I. To get from the center point to the actual circle, we move in a straight line, called a radius. Radius is the measure of that distance. The radius of a circle is one way to measure the size of the circle. Radius is always indicated by the small letter r. Here is a line segment, IE, with endpoint I at the circle's center and endpoint E on the circle itself. If we have two radii, together they can form central angles or a straight line across the circle. A straight line starting on the circle, passing through the center, and reaching to the circle again is a diameter. The diameter of a circle is always indicated by the lowercase letter d. Here is a diameter for circle 2, built by extending radius IE in the other direction, to point P. Instead of identifying that as two separate radii, the plural of radius, we can simply call PE a diameter of a circle. It is the distance across the entire circle. This means radius is 1/2 the diameter, and diameter is 2 times the radius. Here are the formulas for diameter to radius. For polygons, perimeter is the sum of the lengths of their sides. Circles have perimeter too, but we give it a special word, circumference. The circumference of a circle is the distance around the circle. Let's take a look at the ratio of the circumference to diameter in a couple examples. Here is circle 1, with a diameter of 1 meter, and circle 2, with a diameter of 2 meters. The distance all the way around circle 1, the circumference of the circle, is 3.1415926 meters. The circumference of circle 2 is 6.2831852 meters. To form the ratio of the circumference to diameter, we divided the circumference by the diameter. For circle 1, we have 3.1415926 divided by 1, which equals 3.1415926. For circle 2, we have 6.2831852 divided by 2, which equals 3.1415926. Did you notice anything? The ratio of the circumference C to diameter D of both circles simplify to the same value, 3.1415926. C divided by D equals 3.1415926. The ratio of the circumference of any circle to its diameter is always the same value, 3.1415926, named using the Greek letter pi, which looks like this. This is the formula for pi. Now we can use the pi symbol instead of that long number and show a formula of the circumference and diameter. When we multiply both sides of the formula by d, we get C equals pi times d. Now we can find the circumference C of any circle as long as we know the diameter d. If you have the radius, you can still find the circumference of a circle, since radius is equal to half the diameter. We simply change the formula to C equals 2 pi times r. Let's try a practice problem and find the circumference of a circle that has a diameter of 20. Let's start with our formula, then plug in 20 for our diameter. You did it! We can leave our answer in terms of pi, so the circumference of the circle is 20 pi units. Now we know about radius, diameter, and circumference, but there are more parts to a circle left to cover. Imagine you sit down to a delicious hot pizza, but it's not cut. Let's say you cut away a single slice like this. The portion of the crust in the cut pizza is much smaller than the rest of the crust. The smaller portion is the minor arc of the circle. The larger part, the remaining circumference, is the major arc. A minor arc is a portion of the circumference where the central angle measures less than 180 degrees. A major arc is a portion of the circumference where the central angle is greater than 180 degrees. There is more to the minor and major arc, but we will cover that in the next lesson.